Alright, in this video we're going to talk about more with quantum numbers, and then we're going to do several problems here. Okay, so we got 4 quantum numbers. The principal quantum number is called n. We got L number, that's the shape of the cloud, and then we have ML, which is the directions of the cloud, and then MS is going to be the spin of the electron. We talked about that on the first shell. Here we get the nucleus, right? This is the first shell, this is the second shell, this is the third shell, and this is the fourth shell, and so on. So n can be 1, can be 2, can be 3, can be 4. I'm going to go just up to 4. So on the first shell, this is 1 here, this is n equals 2, this is n equals 3, this is n equals 4. So these are the shell numbers. How far from the nucleus? And these electrons are buzzing around in the area, right? Okay. Alright, so here L is going to let us know the shape of the cloud. So on the first shell, we are expecting to get just S kind of orbitals. It's called L equals 0, right? You remember from the previous video. Okay, so L on the first shell, we can have up to L equals 0. I'm just going to write here 0. On the second shell, we are expecting to get 0 and 1 kind of clouds. On the third shell, we are expecting to get 0, 1, and 2. On the fourth shell, we are expecting to get 0, 1, 2, 3, and 3, not 4. So here, 0 kind is called S. They're all called S. On L equals 1 is called P, right? And 2 is called D. And 3 is called F. So on the first shell, I can expect to get S kind of, I'm just going to show you with boxes here, S. And then on the second shell, I have also S. On the third shell, I have S. On the fourth shell, I have S. So these are S. I'm just going to put on the top, okay? So I have 1S here, I have 2S here, I have 3S here, I have 4S here, 4S. So these are sphere shapes orbitals on every shell. The first shell, the second shell, third shell, and the fourth shell. Alright, so we got ML number as well. So what is ML is, I'm going to go more with P and D later after ML. Alright, so on ML, we are talking about the orientation. So for the sphere, it's going to be sphere all the time, so we cannot rotate it. So it's going to be just 0 for S. So it's going to be just 0 for S. It's just going to be 0 for S. I'm going to put like this. This is going to be 0 for this. That's it, right? For p orbitals, we talked about that p orbitals looks like a dumbbell. So we're going to have 3 values. It's going to be x-axis, y-axis, and z-axis. It doesn't matter what directions you are putting those numbers, okay? For p orbitals, we're going to get -1, 0, and +1. We're going to have -1, 0, and +1. So as I put those orbitals on my drawing here, I'm going to put 3 boxes because I get 3 kinds, right? 3 boxes here. Alright, so this is, I'm sorry, we don't have on the first shell p orbitals because see here on the first shell we don't have p orbital, we have just S. So this is going to be 2s, I'm sorry, 2p, this is going to be 3p, this is going to be 4p. Alright, so where is this d orbital? Well, d is going to be ML, for d is going to be -2, -1, 0, and +1 and +2. You can see the previous video how we get these numbers. For F, for D again, -2, -1, 0, +1, and +2. And here for F is going to be -3, -2, -1, 0, +1, and +2. Okay, so here I'm going to erase these numbers right here for now, okay? And I'm going to put the d orbitals in here. So this is going to be d here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, so here I don't have a d orbital on the second shell. I have on the third shell. See here, on the third shell d comes in. On the second shell p comes in. On the first shell we have only s orbital. So here's going to be 3d, here's going to be 4d. And f orbital is going to show on the fourth shell here, but I don't have any space, so we don't need to write here. Okay, so as we see here, we have s orbitals on the first shell, we have s and p on the second shell, we have s, p, and d on the third shell, we have s, p, d, and f on the fourth shell. Okay. So what about ms orbitals, ms number? Well, ms is going to be clockwise or anti-clockwise for every orbital we have in here. All right. So I'm going to show this spin as up and down arrows. All right. So I'm going to go with red in here, and this one I'm going to put up and down, plus f, minus f, plus f, and minus f. So we can put electrons in every orbital. So these are the 4 quantum numbers. So let's talk about now. Let's do some practice now. Okay, so let's do practice. So let's write down all the possible quantum numbers for 3D. And I'm going to do like 2f. There's no 2f. I'm going to do 4f. So what are list all the possible quantum numbers? So I'm talking about 3D here, right? So when I say 3D orbital, I am saying that this is on the third shell. So the shell number tells us the principal quantum number n, right? So for 3D orbital, n will be 3. That's very easy because it says 3D. So we have a d orbital on the third shell. So n will be 3. What is going to be L, what is going to be ML, and what is going to be MS? So here, L number is telling us the shape. So here, L number is nothing but just the coded number for d orbital. So if you have d orbital here as number 2, L will be 2. So whenever you see a d orbital, L will be 2. Whenever you see a p orbital, L will be 1. Whenever you see an s orbital, L will be 0. So what about ML? ML for d orbitals, we got 5 kinds, right? As you see here, I draw 5 boxes, so it's going to be -2, -1, 0, +1, and +2. Okay, so what about MS? So for every orbital in here, for every orbital, we're going to have +½ and -½. So for every orbital, -½ and +½. All of them, all right? And so I can show you like this. So on the third 3D orbitals, we're going to have 5 boxes. 1, 2, 3, 4, 5 boxes. So -2, -1, 0, +1, and +2 for ML. And we can have up and down, up and down, up and down, up and down, and up and down numbers +½ and -½ for d orbital. What about F? What would be the principal quantum number? Well, principal quantum number n will be 4 because it's 4th shell F orbital. What would be the L number? Since F represents L number 3, so we're going to say 3 here. ML can be the same idea here. It's going to be -L to +L if you don't remember from the previous video. So it's going to be -3, -2, -1, 0, +1, +2, and +3. So we got 7 orbitals here, 7 boxes. 2, 3, 4, 5, 6, 7. And every boxes we can have up and down, 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 up, down, and up, down. So MS will be +½ and -½ for every orbital. All right. So now, after this video, we're going to get into electron configurations. See you on the next video.